And so to finish off this lesson, we're going to kind of record it as a separate video, obviously. I wasn't recording all day since yesterday. So we've got 5 tables here. It says, which of the following relations are linear? And for those that are, identify the rate of change. So we can simply kind of look at the table, or we can actually sort of write out the work for the table. We're sort of asking the question, does this on the left-hand side kind of go up by the same amount each time? And if it does, it makes it easier to tell if it's linear. So on the left-hand side, well, 0 to 5 is 5, 5 to 10 is 5, 10 to 15 is 5. So here, basically, we see that it is going up by the same amount each time. It's going up by 5 each time. So all we want to make sure is that on that right-hand side, it is also changing by the same amount each time. Question. So this one on the right-hand side goes up by 9 each time, and you check every single one of those. And so because it goes up by 9 each time, we would say, yes, this is linear. But now the second question was, if it is linear, identify the rate of change. Okay, so remember, the definition of the rate of change was to actually calculate what is that difference in the y values compared to the difference in the x values, right? How much is that right-hand side going up? And compare that to how much the left-hand side is going up. So we don't just look at this and go, oh, the rate of change is 9, because the rate of change in this example is not 9. The rate of change in this example is 9 over 5. Right? So the rate of change is the change in the y values, so you do look for that, over the change in the x values. And since they're consistent, we can just sort of quickly look at that and say it's changing by 9 each time, it's changing by 5 each time, so this rate of change is 9/5. Okay, which you could use it as, you could get it to a decimal, right? So 1.8. Most of the time it's better to leave it as a fraction. Okay, so that's the first one. The second one, basically look for the same thing. All right, 0 to 5, 5 to 10, 10 to 15, 15 to 20. So again, looks like this left-hand side is going up by 5 each time. So now we look at the right-hand side. We say, well, what's it going up? Is it going up by the same amount each time? And so from 0 to 75, that's going up by 75. And then right away you say, well, 75 to 300, that's not going up by 75. And so since it doesn't go up by the same amount, we would say that this one is not linear. And because it's not linear, we do not evaluate a rate of change because it's not consistent. So we're done. All right, make sense? Okay, so I had asked you to do, basically try all these 5. And so what I'll just simply do is go through the last 3, and if we need to walk through any of those, we will. So this next one here, far right-hand side, this one is linear. And the rate of change that we get out of this one happens to be 100 over 3. Okay, so any questions on how we got either of those? Okay, next one down here on the left-hand side. This one here is also linear. And the rate of change on this one works out to be 3. Okay. And then the last one, bottom right-hand corner here, we'll do this in blue again. This one is also linear. And this one here has an interesting rate of change. The rate of change is actually negative. It's -4. Because as you look at the x values go up, but the y values go down. And so that means the rate of change for that particular table happens to be negative. Okay, so any questions from that sort of table? Simply looking and saying, how can I tell if it's linear or not? and I simply look for the change in that independent variable, comparing that with the change in the dependent variable. And for some of them, it's easy. You can just simply see it goes up by the same amount each time. This sort of bottom left-hand one here is a good example because it doesn't go up by the same amount on that left-hand side. And so you have to do a little bit more work to see, well, what's the rate of change from those first 2 points, between the next 2 points, and between the next 2 points, and you see that it ends up being the same. Question, Caleb? Okay, which question are you looking at? So, like this one here? Well, so you're asking about the y value? Well, I don't see a y value of 0 here anywhere. And so you don't, right? You don't know where it starts. I mean, so it's a good sort of observation. We don't know what x value would produce a y value of 0. Now, we could figure it out eventually, but considering the table, the only one where we see the y value of 0 is here. So we can't tell. Now, here's what we maybe could do, right, is we could say, well, can I keep going backwards here and get down to 0? Well, in this case, to go sort of backwards, you're going to be subtracting 9 each time. Well, you'll go 32 minus 9 is 23. 23 minus 9 is 14. 14 minus 9 is 5. 5 minus 9 is negative 4. So you actually don't get a 0, at least not with a nice sort of number there. Not that we can't, not that we won't, but you can only take the numbers that are in the table to work with them. Okay. Okay. Any other questions about the table ones? Right. And then the last example in the notes. Okay, so the last example says, well, instead of given a table of values, if you're given an equation, how can you tell which ones are linear or not? Okay, and we're not going to necessarily sort of look here at the rate of change, but how can we tell if one of these relations or which of these 5 relations could be linear? All right, so there's sort of 2 things that you can do. All right, given each equation, how can you tell which ones are linear? Well, one thing that you could do is create a table of values. And then sort of compare. And I'm starting to lose my pen here at the top. Okay, so create a table of values and compare. And in terms of creating a table of values, I would recommend five ordered pairs, right? Create a table that has 5 rows. So in this particular one here, you kind of say, well, this kind of looks boring. This is x is equal to negative 2. So if x is equal to negative 2, what's y? And the answer is, well, I guess y could be whatever you want it to be. If x is negative 2, y can be whatever you want it to be. This is kind of a tricky one, right? You could use 0, right? And in terms of graphing that, negative 2, 0, negative 2, 0 is a point where x is equal to negative 2, so there's nothing wrong with that. Negative 2, and could you put a 1 there? Right? Does this satisfy the equation where x is negative 2? And the answer is yes. So you can actually put in here any ordered pair that you want. As long as x is negative 2, y can be any value. And because y can be any value, that means that the rate of change here, we can make it the same. Right? We can make it the same so that it can go up by 1 each time, or we can make it go up by 2 each time. Because the fact of the matter is this doesn't go up by anything. All right? So this one here is linear. Now, in terms of the equation itself, right, simply by looking at the equation, there is a way to tell if the equation is going to be linear, and that is that x and y. Tell you what, I'm gonna write it down below because I think my pen sort of works a little bit better down below. It's going to be linear if x and y have only exponents of 1 or 0. Okay? That's what makes something linear, is if x and y have only exponents of 1 or 0. And so this first one, right, x equals -2, the x has an exponent of 1. The y has an exponent of 0 because it's not there, right? Remember, anything to the power of 0 is equal to 1. So this one here, x has an exponent of 1, y has an exponent of 0. If you take a look at question B, without creating a table of values, do you think this one's going to be linear or not? Yeah, this one's going to be linear because your y has an exponent of 1 and your x has an exponent of 1. Okay, and then this one totally works. And I can kind of show you. If I use a graphing program, because maybe many of you are interested and you're looking at that x equals -2 and you're wondering, is that really a line? And the answer is yes, it's a vertical line where x is equal to -2, right? And so is it a line? The answer is yes. Right? The second example there, right? Y is equal to x minus 25. Okay, there's our nice linear relation, right? Nice straight solid line. Example number 3, y is equal to 15. Right? We simply look, and again we ask ourselves, well, what are the exponents on x and y? Okay, so this one here was a yes. This one here, the y has an exponent of 1, the x has an exponent of 0, and so that's okay. This one here will also be a linear relation. Question is, well, what's it going to look like? Okay, so the y equals x minus 25, where you have both x and y, gives you kind of a slanted line. The equation where you had just x gives you a vertical line. So take a guess at what the equation y equals 15 is going to look like. Right? The equation y equals 15 is just a horizontal line. Okay. All right, looking down at the question D, y is equal to x squared plus 5. Okay, so the y has an exponent of 1, but the x has an exponent of 2. Right? And in order to be linear, x and y can only have exponents of 1 or 0. So this one is not going to be linear. Okay? In fact, here's what it looks like. Y is equal to x squared plus 5. Y is equal to x squared plus 5. Okay, you see this curved sort of function, right, or curved relation. So because that x has an exponent other than 0 or 1, we know that this one is not going to be a linear relation. And then this last one here, it's written kind of differently. It's not written y equals, but it's written x equals. So again, we simply look and we say, well, the x has an exponent of 1. The y also has an exponent of 1. So our answer for this one is going to be, yes, it's going to be linear. Okay, so that's just kind of quickly looking at an equation, and how can we tell if an equation will give us a linear relation? And the key is right there. If x and y have only exponents of 1 or 0. Okay. And so that ends the lesson part on sort of the properties of linear relations. And on the back of your handout, excuse me, or at the bottom of your handout, I'm not sure where it is. I think it's the bottom, yeah, because it's not quite the back page. Your practice questions are on page 308. Question. Okay, handouts are all available on the shelf at the back if you miss any particular lesson.